There is a river inside the ocean. It moves more water than all the rivers of the world combined. It carries the heat of the tropics to the grey skies of northern Europe. It is the reason you can grow wine grapes in Bordeaux at the same latitude as the frozen forests of Newfoundland. It is a planetary radiator. It is not expected to fail. But if it did, we call it the AMOC, the Atlantic Meridional Overturning Circulation. It acts as a massive global conveyor belt. Warm, salty water flows north from the Gulf of Mexico, cooling as it reaches the Arctic. When it reaches the Labrador Sea and the Nordic seas, it becomes cold and dense, heavy. It sinks to the bottom of the ocean, a process called deep water formation. This sinking is the engine. It pulls more warm water north to replace it. The scale is staggering. The flow is measured in sverdrups. One sverdrup is 1 million cubic meters of water per second. That is the equivalent of roughly 400 Olympic pools of water moving past a point every single second. 5 times the Amazon River, 60 Mississippis. Enough daily water to approximately 6.6 billion people every single second for one sverdrup. The flow of the AMOC is between 15 to 18 sverdrups, roughly 75 to 90 Amazon rivers moving continuously every second. Some currents are even larger. The Antarctic circumpolar current, for example, transports on the order of 100 to 150 sverdrups, making it one of the most powerful flows on the planet. In terms of energy, the AMOC transports 1.25 petawatts of heat northward. That is equivalent to 60 times the current energy consumption of the entire human civilization, strictly dedicated to keeping Britain and Scandinavia warm. This system is stable, but it has a tipping point. It exhibits what physicists call hysteresis. Once it stops, it is extremely difficult to restart, and it has happened before. About 12,000 years ago, during the Younger Dryas period, a massive glacial lake burst, flooding the North Atlantic with fresh water. The circulation collapsed. Temperatures in the northern hemisphere plummeted by 10 degrees Celsius, 18 degrees Fahrenheit, within a decade. Current climate models suggest a sudden collapse is unlikely in this century, but the circulation is already at its weakest point in 1,000 years. We are assuming, for this scenario, that the melting of the Greenland ice sheet hits a critical threshold today. The trigger is density. Salt water is heavy. Fresh water is light. As the Greenland glaciers melt, they dump billions of tons of fresh water into the North Atlantic. If this freshwater lid becomes too thick, the salty water from the south cannot sink. The engine floods, the pump stops. It is a suffocation. The vertical movement of the ocean ceases. The first witness is not a human. It is the Rapid Array, a line of mooring sensors stretching from Florida to Morocco. The sensors measure current velocity. Suddenly, the deep velocity readings drop to near zero. The data packets travel via satellite to the National Oceanography Centre in Southampton, UK. A scientist looking at a monitor sees the heartbeat of the ocean flatline. There is no sound. No wave crashes differently on the shore of Cornwall. But physically, the kinetic energy of the Atlantic has just been turned off. This is a counterintuitive physics effect. The rotation of the Earth pushes the Gulf Stream to the right, towards Europe. This force pulls water away from the American East Coast. When the current stops, that force disappears. The water relaxes back toward America. Within hours, tidal gauges from Boston to Cape Hatteras register a sudden, inexplicable surge. It isn't a storm, it is the ocean losing its tilt. In Miami, sunny day flooding begins filling the storm drains of Alton Road, not from rain, but from the sea leveling itself out. The ocean drives the atmosphere. Without the heat release in the North Atlantic, the jet stream, the high-altitude wind that steers weather systems, begins to buckle. It creates a blocking pattern. Weather systems stop moving. If it is raining over the wheat fields of Ukraine, it stays raining for weeks. If it is dry over the reservoirs of Spain, it stays dry. The weather becomes stuck. Winter arrives early, and it does not leave. In Ireland and the UK, the temperature anomaly becomes undeniable. Without the 1.25 petawatts of heat, the average temperature drops by 3 degrees Celsius to 5 degrees Celsius. This sounds small. It is not. It is the difference between a winter in London and a winter in Quebec. In the vineyards of Burgundy, frost kills the vines in late spring. The European agricultural engine stalls. Meanwhile, the heat that is no longer moving north has to go somewhere. It stays south. The waters of the Caribbean and the South Atlantic become superheated cauldrons, fueling hurricane seasons of impossible intensity. The port of Murmansk in Russia is the only ice-free port in the Arctic Circle, kept open by the warm current. Without it, the ice returns. Shipping lanes across the North Atlantic become hazardous with sea ice drifting as far south as New York. Global shipping insurance premiums skyrocket. The cost of heating Berlin and Paris triples, straining an energy grid designed for a temperate climate, not a boreal one. The deep water formation does not just move heat, it moves oxygen. It breathes for the deep ocean. Without this mixing, the deep Atlantic begins to lose oxygen, anoxia. Deep sea ecosystems, unseen for millennia, begin to suffocate. Commercial fisheries in the North Sea, dependent on nutrient upwelling, sea catches collapse. Cod and haddock stocks migrate or die. The most tragic effect happens far from the ice. The thermal balance of the Earth dictates the tropical rain belts. As the North cools, the Intertropical Convergence Zone, ITCZ, shifts south to compensate. The rains that usually feed the Sahel region of Africa and the monsoons of India fail. Billions of people rely on this seasonal clockwork for rice and millet. The crisis shifts from shivering in Europe to famine in the tropics. Models disagree on the speed. Some suggest a slow decline over a century. Others suggest a tipping point collapse could happen in a decade. We also do not know how much the atmospheric heating from greenhouse gases would counteract the cooling from the AMOC shutdown. Would Europe freeze? Or would it just stop warming while the rest of the world burns? It is a tug-of-war between fire and ice. Civilization has existed entirely within a remarkably stable climate period called the Holocene. We assumed this stability was a permanent flaw. It is actually a tightrope walk. The radiator of the Western world is not a machine we built. It is a fluke of geography and salt. We do not control the pump, we are just passengers. It is not expected to stop. But what if it did?